So, hello everybody, welcome to the first English webinar, Programming and Working with Touch Probe Cycles and Touch Probes. My name is Michael Wiendl. I'm an NC trainer for NC programming here at HEIDENHAIN Traunreuth, and I want to show you now in the next 60 minutes our touch probe systems and also the probing cycles in manual and automatic mode. So HEIDENHAIN offers a lot of touch probe cycles, especially for workpiece measurement, set datum, and also alignment of the workpiece. And we also offer cycles for tool measurement. So for the first measurement, for brake control, and for tool wear measurement. We can use the cycles in manual mode, when we only have one workpiece for setup, or we can use it also in automatic mode when we want to do a touch probe cycle in NC program, for example. So at first, the settings. Here I show you two different settings. The first settings is for the iTNC 530. So there we need to do a lot of settings in the machine parameter. So to enter the machine parameter, you press Programming and Editing, then the mode key. Afterwards, you type in the code number 123. This is the number for the end user machine parameters. And then you can navigate with the go-to key to the different machine parameters. And there I just show you the most important machine parameters for probing system. It's the first one, the 6120. This is the probing feed rate. So here you define the feed rate for probing. This is a very important feed rate because I show you later the working procedure of a probing system. And for this, it's important to know or to set the exact probing feed. If you change the probing feed rate, then you need also to calibrate the probing system one more time before you restart working. Then the next parameter, the 6130, is the maximum traverse to the first touch point. So, for example, you standing in front of the workpiece, and then you need to define the direction. So if you define the wrong direction, then the probing system will drive this traverse, and afterwards, when there is no touch point, so no contact on this traverse, the error message that there is no touch point hit it, and so we can easily we can stop it here, the probing. So this maximum traverse should be not more than the length of the stylus of your probing system. So if you are, if you want to make a set mapping, then you can, and you do not hit the workpiece, then it's better that the control will automatically stop after the length of the stylus. Otherwise, you will get a contact to the, or you will crash the probing system. So this maximum traverse should not be longer than the length of the stylus of your probing system. Then the safety clearance to touch point. This parameter 6140 is for our automatic cycles. There we always have the safety distance or safety clearance, and this is always calculation, the value from the machine parameter plus the value from the cycle. And so here you type in the radius of the wall of your stylus. Then we have feed rate, rapid traverse for pre-positioning, and if the pre-positioning should be done with the rapid traverse from the machine or from the touch probe. And also the 6161, align touch probe before each measurement. This is for a better accuracy. So the touch probe system will be aligned before every measurement. So you always touch with the same position, for example, 0 degrees of your touch probe ball. So this is then the more accurate way. The same functions we have also for our NC kernel controls, the 128, 320, 620, and 640. But there it is defined not in the machine parameter, there it is defined in the touch probe table. So you push the key manual operation, the soft key touch probe, and then you have the touch probe table, and here you can define not only one settings, you can define different settings. So also the same settings like you have on the iTNC, so probing feed rate, maximum traverse, setup, Fmax, and the track. So there you can also define the different values. So a little overview for our touch probes. So I want to show you the new generation from our touch probe systems. So you see here we have wired touch probe system and also wireless touch probe systems. It's, for example, the 460, the wireless touch probe system. And we have also tool measurement systems, also wired and wireless systems. Also new from our the new generation touch probes, they are so with the same technology, they have a smaller dimension, so you can get easily better into the workpiece. For example, in a drilling, then you can also measure in the drilling. You can also use normal batteries. Also new is the hybrid technology, so you can switch with the probing systems between infrared connection or transmission or radio signal transmission. The difference here, infrared you can use up to 7 meters. Infrared is a faster transmission, but infrared has one disadvantage. The detector, the detecting system needs to see the touch probe system. So, for example, if you are if you go with the touch probe system inside of your workpiece and there is complete metal around the touch probe system, then there is no possible connection with infrared. So then you can switch to radio. So radio you can work up to 15 meters. And you do not need a direct view or direct connection to the touch probe system. So for bigger machines, for machines when the touch probe system is behind the workpiece, then it's better to use the radio signal. You can easily switch it at the SE66 here, and then you can switch between radio and hybrid. And also an advantage of the new generation of probing system is the collision protection. You see it here. It's just a small part which you mount between the probing system and your tool holder. And this small part makes just one thing. If you get a collision with a clamping system, as you see on the, then the probing system will be switched off automatically, and so the control will stop. So you are so not only the stylus is protected against collision, also the touch probe body is protected against collision. And also we have a thermal decoupling. So if the spindle gets warm, then the temperature will not go into the probing system, for example. So these are the function and advantages of our new generation of probing systems. Then I want to talk a little bit about the measurement method. So that's also why we need to calibrate it when we change the feed rate. So you see here, it's inside of the touch probe system. There we have 3 components. The first one is the lamp. Then here we have in the middle the stylus, and inside of the stylus there is a lens. And on the right side there you have the photo element, and there you just get the signal from the lamp on this small element here. So as you see here in the not probe position, so in the neutral position, there is no signal. So if you move the stylus, for example, for X and Y or Z measurement, then the stylus will be moved, and with the stylus, the lens will be moved. And so the point on the photo element will go to the detection, to a field where the light is detected, and so I get an electrical signal. And this is the measurement point, or the probing point, when the control gets the information, okay, now there is a probing. And because of this, we need to calibrate the probing system if we change the probing feed rate. Because the detection, or the way, the distance, when until the control will register the signal, is higher when you, or is longer when you have a higher feed rate, and this must be always calibrated. The same is for a tool measurement system. There you have the same technology inside of your touch probe here. Calibrating the touch probe, an important thing, because only if we have a calibrated system, then our results are also reliable. And if we do not have a calibrated touch probe system, then our probing results are not useful for us. So it's always important to have a good calibrated touch probe system. So the first, what we should do, we should center our touch probe. So centering, put your touch probe system in the spindle, and then you just put a little measuring clock on the stylus, and then you turn around the stylus 360 degrees, and there should be not more difference than plus minus 3 micrometers. If there is more, then you need to open the screw and fix it a little bit again, and then just push a little bit against the body of the touch probe systems, and then you can center it. The rest of the plus minus 3 micrometers you can also center with our electronic way. So then we have an electronic compensation for the center offset. But you should center the probing system correctly. Also for other probing cycles, for example, KinematicsOpt, it is necessary that you have also a good centered touch probe system. So do not only use the electronical centering, also use the mechanical centering. Then we have different cycles for calibrating. At first, we need to calibrate the radius. So there is only at the iTNC 530, there is only one possibility. You need to calibrate the radius inside of a ring. So you need to know the exact diameter of the ring. You make a preposition inside of the ring. You type in the radius of the ring, and then you push NC start. Then the probing system will be calibrated to this diameter of the ring. So the control knows the diameter of the ring, but the control does not know the radius of the probing system. So the control measures the radius of the ring, and for this radius, the control will calibrate the probing system. So then you have the correct calibrated radius for your probing system. For calibrating the lengths, there you can use different ways. I prefer the calibration with a milling tool because I do the milling processes with a milling tool. So when I mill a surface, and this surface I program with Z0, and afterwards I change in the touch probe system and I measure the surface, then the surface should be Z0. And to get the combination from the milling tools to the probing system, I always calibrate my probing system with a milling tool. The way or the operation is always the same. At first, I mill a surface with my milling tool, not roughing, finishing. On this surface, I say Z0. Then I change in the probing system and I calibrate the probing system on this surface. Then the lengths of the milling tools are combined together with the touch probe system. So for example, you can also measure the milling tool in an external system, and then you can bring it to the control, insert the values in the tool table, and then start with the calibration here. The second one is a calibration with a pin. So we have here a special setter, zero setter in the machine. And there you have a flexible part inside, and you have also a not flexible ring outside. So this needs to be the same height. So put 0 to this 2, as you see on the picture. Then we drive with our zero setter on the inner part, on the flexible part. And here we say Z0, and then we calibrate the probing system on the outside ring. Then, for example, this tool or the calibration pin is the calibration pin for calibrating our our tool measurement system, the laser or the TT. And then we also have the combination from our measuring or calibrating the tools to the calibrating or measuring with the probing system. And also possibly you can do it with a gouge block, but this is only for with the spindle nose. So there you need to be careful which workpiece clamping system or which tool clamping system you have. That also the gouge block or the spindle tip is 0. So it's better to use a tool or, as I said before, a calibration pin. Please do not calibrate or measure your probing system in an external tool measurement system, because we always need to calibrate our probing system with the electrical signal. So not in the neutral position. So we need the point when the signal will go to the control. Because of this, you are not allowed, or it is not allowed to calibrate or measure the probing, the touch probe, with an external measurement system. Then you get the wrong results. Next step is the datum table. So our preset table, there we save all the datums. Preset table we can use for different machines. You can use it with a 3-axis machine. Then the preset table always, the values will go to the 0 point of the machine. Also, if you have a machine when all the round axes are in the head, then it's also to the middle, to the 0 point of the machine. Machine with a round axis in the table, for example, an AC table, then the preset table the values will always go to the middle of the last round axis, so for example the Z-axis. Also, an advantage of the preset table, you can use for every line a own basic rotation. You can also do probing in the tilted system, and the lines have no connection together, so every line is stands alone for it. So there's no combination between lines. All the lines from the preset table are just looking at one point, the 0 point or the middle of the table if you have a round axis in the table. If you open the preset table, you see the first line, the line 0, is red. So this is always the last manual set datum. So if you press the key set datum in the manual mode, then this is saved in the line 0 of the preset table. So this line 0 is also protected against changing, so you cannot go into the preset table and make any changings in line 0. You can make changing in the other lines, but not in line 0. To activate a preset, you always see preset in the status of your control. There you see, for example, at the moment the active preset is 5. You can activate it manually. If you open the preset table and say, go to the line and say active datum, then it's activated manually. And you can also activate it in the program with a cycle 247. There you can activate also a datum out of a program, for example. So now the manual probing functions. There we have different probing functions. For the first two are for calibration, the length and the radius. Then we have different probing functions for probing rotation, so the basic rotation for with two drillings, or we also can do compensation of the basic rotation with the table. And we also have different functions for set datum. If we start our setup for the workpiece, the first thing what we do is the basic rotation. So our workpiece is not clamped parallel to the machine coordinate system. So normally we need to compensate the not parallel workpiece with mechanical way. So just measure and just changing the position of the workpiece. But we can also do it with a function from the control. And this is the basic rotation. For basic rotation, we need two probing points. For example, along the X plus axis, two probings in the Y plus direction. And then we can easily measure the angle between the positive x-axis and the workpiece, and this angle is saved in the preset table in the column rotation rot. And then from this point the machine is not going parallel to the machine coordinate system. The machine is driving parallel to the workpiece. And also the basic rotation will not be resetted when you switch off the control, so it is activated until you deactivate it. Also important, you need first probe the basic rotation and then set the datum with the active basic rotation. To reset the basic rotation, you just enter in the manual operation and type in 0 and end of block, then it's resetted again, or you can use the cycle 404 or the M function 143. The next step is then set the datum in any axis that we will make later at the machine. And we have the same functions also on our new NC kernel controls, the 128, 320, 620, and 640. There we have a little bit less functions from the number of functions, but the functionality of the functions are really better than the iTNC functions. So, for example, you have only one soft key probing rod, but in this probing rod there are 5 soft keys from probing rod from the iTNC. So this is a really good function. Also, you have probing plane, probing position, probing point with 2 lines, probing CC, circle center, probing CL, center line. This we will watch later at the machine. Probing rod you can also use for table rotation. Probing CC. Also calibration functions. On iTNC you only have calibration the length and calibration the radius with a ring. You can, on the NC kernel controls, you can also do a calibration with a stud or with the calibration ball from the KinematicsOpt. So these are also 2 new calibration functions. Also, they are possible in the manual, in the automatic probing cycles. So there we have 3 new cycles, 461, 62, and 63 for calibration automatically. Also, an opportunity if you do not have a probing system, then you can also, an electronic probing system, then you can also do all the manual probing functions with a 3D touch probe, with a manual or mechanical touch probe or a tool, for example. So you just insert the tool, to the workpiece, to the near of the workpiece, and this position where the tool will put off some chips, and then you just take the position key, and then it is the same as you do with a probing system. With the probing system, you push NC start. This is not possible with a mechanical system, but you can make a pre-position, and on the position where you want to make the measuring, then you just take the position key, and then it's easily to use also all the manual probing functions with the mechanical probing systems or a tool. So now I change to the machine. Okay. So now you see on the right side the camera view of the machine. There will be a little bit time shift, so do not wondering about if the touch probe system is jumping a little bit. There is just a time shift between the camera and the webinar here. And on the left side, you see the manual, the view of the control, the screen of the control. And now I want to start with our workpiece here. And the first thing what I want to do is I want to make a compensation of the of my side here, of the length here, of this surface. So on this surface, I want to do a basic rotation. And for this, I just do a pre-positioning with my probing system. This is, for example, an TS460 probing system. And the probing system, when we start with our probing functions, the values from the probing system is stored in the tool table. And there we have our probing functions. And the main information is the TPNO. It's the touch probe number. So the tool number is 64 and the touch probe number is 3. So in this tool number 64, there is insert the length and the radius. This is the calibrated length and the calibrated radius. The TP number, the touch probe number, says with which line of the touch probe table the probing system should work, and the touch probe line is in the touch probe table. And here you see our touch probe system is working with the line number 3. And here we have our settings for the probing. For example, probing feed rate of 1000, maximum feed rate 5000. Then the distance is 50, so the length of our stylus. The setup is 5 millimeters, so the safety distance. And I also set track on. So before every probing, for every measurement, the probing system will be aligned automatically by the control. So I can insert a lot of lines here. So this is TNC 640. So not an iTNC. These values are only available at the new NC kernel controls. And we are here, for example, at an TNC 640. So we are activated the probing system with our tool call for 64. And now we want to do the first probing rod. So when we press the key probing rod, then we see here in the pictures, we need 2 probing points, the first and the second. If the first point is on the left side and the second is on the right side, then I get the angle from X plus to the workpiece. If the first point is on the right side and the second point is on the left side, then I get 180 plus angle. So it's just for me as an information what I need of the sequence of my probing points. And I also have in the soft keys, I have the directions, X plus, X minus, Y plus, Y minus. Also that axis, so I can also do it in the tilted system, or also only in the inclined system. So when the A-axis is, for example, on 90 degrees, then I can also do the basic rotation with the Z-axis, for example. And I also have the opportunity to set the basic rotation with a circle inside or outside. So with a pocket or a stud. And this I can define however I want. So you can say I want to set or measure the basic rotation with a stud and a pocket, or with an one-axis direction and a pocket, and one-axis direction and a stud. So this is just an automatically way where you can have a lot of variety for measure the basic rotation. Okay, I did already a preposition, so I want to do an Y plus measurement. So I push NC start, and the first point is probed. So I do a preposition in the X plus. Just waiting for the webinar. So now you see also the X plus changing, and now once again Y plus, NC start. Okay, so now I measured 2 points and I get the result. The result is here, angle of rotation. It's 2.87. And now I can decide what I want to do with this basic rotation. So I can say set basic rotation, soft key number 1. Then the basic rotation is saved in the line 0 of the preset table as a basic rotation. So when you say a basic rotation, then the coordinate system will be aligned to the surface of my workpiece. So this is the basic rotation. You can also say set basic rotation in preset table. Then you need to insert a value in the field number in table. For example, when I say here number 5, and I say basic in preset rotation, basic rotation in preset table, then this rotation will be saved in the line number 5. So the first two soft keys are the basic rotation, and then I also have 3 more soft keys. It's for the table rotation. So I can also compensate this 2.8 degrees, not with a basic rotation. I can compensate it by a moving of the round axis. So here the table axis is C. So when I say set table rotation, then this value will be saved in the C offset of the preset table, and the table will be then aligned to 0, and then the workpiece is once again parallel to the machine coordinate system. So it's just for you to know, you can work with a basic rotation, or you can work with a table rotation. Please do not combine these together. So basic rotation and table rotation, then you get a wrong result. You can, if you have a 3-axis machine, no round axis in the table, then you need the basic rotation. If you have a round axis in the table, then normally you use the table rotation. For our example here, we say set basic rotation. So I want to save it in the preset table in the line 0. And I just leave it here with end. So, and now we have a new symbol. It's here in the status. You see over the green when you from the touch probe. Then if you go up, you can mark it, I think. Yes. Here you see the new symbol. It's for basic rotation active. Also, when we go into the preset table, here we see SPC. This is the column rod from the iTNC. Here is now saved the basic rotation. The other values, X, Y, and Z, are at the moment not measured, so I just know from my workpiece now the basic rotation. And now it's important when you save it in another preset line that you activate the preset line before you start now probing or set datum. Because for set datum, we need to compensate, or the control needs to know the information from the basic rotation. So next step is, once again, touch probe, probing position. Okay. And now I want to do set datum, Y plus axis, and C start. Okay. So now I get the information of the measured value, and I say datum set. Then it's also saved in the preset line 0. I can also say enter in datum table or entry in preset table. Entry in preset table and datum table is always working with the number in table. But you should use the preset table because only the preset table is in the reference system of the machine. The datum table is always in the workpiece coordinate system. So you should always work with the preset table for set datum. Okay, the first axis was the x-axis, the y-axis. The second one now is the x plus, so probing position, x plus, and NC start. Okay. So, and now datum set again. Okay. And Z plus So preposition for the Z minus. Okay. So we say here Z minus, probing position, Z minus. And here you also see the soft key take the position. So for example, if you do it with a mechanical system, then you go to the probing position and then you say take the position at this point. So we have an electronical probing system, so we say Z minus and NC start. Okay. And this value should be minus 20 and set datum. Okay. So now our workpiece is probed completely. So I can go away from this position here. Okay. And I can just control the preset. I program linear x0, y0, z0. Preset is activated and I start with the pre-positioning. Okay. So position is correct. We are standing at the front left corner and on the Z0 position because my probed surface was the minus 20. Okay. So there are also other probing systems, probing functions. So we watched now the probing rod. So it's also possible to do the rotation with a table rotation. You can also do it. I just delete the basic rotation. Okay. And approach probe, probing rod. For example, I want to do the probing rod with the two drillings. So the drillings I want to use this drilling here and the right drilling here. So these two drillings I want to use for the table rotation, for example. So make a pre-position. Okay. Okay, when I'm inside of the drillings, I say probing rod. And now I choose the insert circle, inside circle. And I push NC start 1, 2, 3, and 4. Okay. So now the first position is measured. I go up and make a pre-position to the second. Okay. It's not good if you hit the workpiece between the pre-position, because then the stylus will bring an error message that stylus in contact. So I need to do it again. Okay, probing rod. And NC start 1, 2, 3, and 4. Okay, and pre-position to the next point. Okay, and circle once again, and NC start. 1, 2, 3, and 4. Okay. So now the same information, but now I want to use the table rotation. So I say set table rotation. Okay. So now you see it in the C-axis, in the value of the C-axis, there we have a changing. So now the C-axis is not on 0. Now the C-axis is on 375. 357, sorry. So now I can also say align the rotating table, okay? So I get the information, please pre-position. The control wants to drive the C-axis to 0, okay? I am in a pre-position. I can say NC start, and then the table is moving. Now you see C-axis is once again on 0, and now my workpiece is compensated. The table rotation is always saved also in the preset table, but not in the SPC. It is saved in the C offset. So these are the two different columns where compensation is saved. You have SPC for basic rotation, and you have the C offset for table rotation. Okay? Then you also have different other probing functions, probing CC for circle center, and probing CL, for example, for center lines. So left side and right side of the workpiece, and then the middle of these two probings here. And on the second soft key floor, you have calibrating TS, and there you have the different calibrating functions. Okay, so we come back to the presentation. So the same what I did now as a manual operation or manual probing, I can also do with automatic functions. There we have different probing functions. We have, the first is the measuring of the misalignment. So our basic rotation and table rotation automatically. And the next soft key is the datum setting, so for set datum. And we also have the workpiece measurement. And some special cycles for calibrating or save kinematics for KinematicsOpt, for example. For an automatic probing function, it is important that we now need to define all the values, what we did as a manual preposition. This must be defined now in a cycle. So if you do not know where the workpiece is in the machine, then you cannot use a probing function. So before you are working with a probing functions, you need to set a datum which is in the near of the workpiece, that you will find the workpiece later on the machine. So this is important. You cannot make for the first setup, you cannot use an automatic probing functions, but you can use it automatically in the program for milling a lot of workpieces, for example. So we will watch at the cycle 414, datum outside corner. There you have different values which you can decide. You can also combine it with a basic rotation. You can make an X and Y datum and also a Z datum. So the combination of the three probing functions, what we did before. So at first basic rotation, then set datum in the X and Y axis, and then set datum in the Z axis. You can also do the table rotation with an automatic cycle. It's the cycle 403. And for this, we will also do now a little practice at the machine. So once again, back at the machine, but now we are not in the manual. Now we want to do an automatic probing. So at first, I activate, or I just drive the C-axis to the 0 position, so C0, M91. Then I activate the line number 1. I want to work with the line number 1 to save the preset there. Reset the basic rotation is M143. And then I have the probing cycle. It's touch probe. And set datum. Okay. And now you have different probing functions here, different cycles. You see in the middle of a stat, middle of the pocket, middle of a stat, middle of a circular pocket, middle of a circular stat, and the corner of a rectangular stat, the corner of a rectangular pocket, and also different other values or cycles what you can use. So we want to use the cycle 414. And now we need to program all the values what we did in the manual mode by ourselves. So we need to say the first point, the first axis for probing. So this should be plus 10. So the x plus 10. And the y-axis should be 0. Then the spacing in the first axis, so the distance between, I say 50. Then the third point. So on the left side, I also want to do 2 measuring points. So the third point should be 0, the second point 10 millimeters, and the spacing between the axes should be 50 also. The measure 8 minus 25. The setup clearance, and here you see now, it's, if you watch it's the setup from the touch probe table plus the Q320. The clearance height, let's say 30. Move to clearance is if he should between the first and the second probing point, so between the 2 probing points for the first side, if he should to clearance. For example, if there is a clamping system, so we do not have there a clamping system, so I say 0. The next step, do I want to have a basic rotation? Yes, I want to have a basic rotation, so I say 1. And the number in the preset table should be 1. The preset, so the datum, what should be afterwards should be 0, 0. So at this measured point, so from this 2 line, where the 2 lines will connect, there should be afterwards x0 and y0. Then the point should be saved in the preset table, 1. And there should be also an probing in the z-axis. So I say 1. And then I need to define the coordinates for the probing. So x70, y5, and the third is minus 20, and it should be here minus 20. So you need to define every value what you need, where you want to do your probing. Okay, so we change to program run, full sequence. So we start here, line Z0. Just reset the C offset. Okay. Now I can say set datum C0. Okay. So now we make the preposition to the first probing point. Okay, number 1. And number 2. Then preposition to the next side, to the second side. Number 3. And number 4. Okay. And then preposition for the Z-axis and preposition once again also in the Z-axis. And then save position. So now we set the datum automatically with a probing cycle. And the probing cycles you can easily use by your own. It needs just a little bit practice. So just clamp the workpiece and start with measuring. So it's always important if you work with rotation, for example, that you at first measure the rotation and then activate the preset where you saved the rotation inside. Okay. A very important function from our automatic probing functions is the function KinematicsOpt. Now, KinematicsOpt is a probing cycle. You for your 5-axis machine, so with 5th and 4th axis, you can use the KinematicsOpt to make your machine more accurate. So behind the machine there is the kinematic description. So you in the kinematic description there are the turning points defined of your round axis. So they are 1 times defined from the machine tool builder. But if you get a difference because of temperature or machining processes, then you can use KinematicsOpt to set again the round positions of your axis here. And this is an easy cycle. You have a cycle 450. With this cycle you can save the kinematic. Before you do any changings, it's good to save it. And then you have the cycle 451. It's for measuring, so test or write the kinematic. And there you just define the starting angle and the end angle of your round axis. And then you can, the control will measure between the start angle and the end angle with your measuring points. Will always measure the middle of the calibration ball, which you put on your table, and you measure the middle of the calibration ball, and you get from every inclined measurement, you get an other middle of the ball. If you have a perfect machine, then it will be always the same. But a mechanical machine is not the theoretical perfect machine, so you get there a little different. And now the control calculates and tries to change the round position, or the middle position of the round axis, to get a better result. And this is the result with your KinematicsOpt. So you will just get a more accurate machine, but the machine, the construction of the machine must be also good, that this measuring is also reliable. So KinematicsOpt, there will be another webinar for KinematicsOpt when we are talking 1 hour only about KinematicsOpt. So for you as an information now, it's just KinematicsOpt is for optimization the machine to get a more accurate tilting and inclined machining result. And for this you can use the KinematicsOpt cycles. Okay, that's all from my side now. So